another video. In this video, we're going to learn how to solve problem sum based on game theory or theory of game under the method principle of dominance. Okay, again, a very important topic for all the TYBMS SEM6 student. In this, we are going to take up three sums in order to understand the concept how to solve the game theory sums based on principle of dominance. So first, we'll note down two rules or two principle that we need to learn if you need to solve the sum based on this particular rule, that is principle of dominance. Okay, so first we'll note down the rules and thereafter we'll be solving three sums in order to understand the concept. Chalo. Okay, now before starting the sum based on principle of dominance under game theory, okay, first let us note down some rules, okay, which will help you to solve any kind of sum based on principle of dominance. Okay, there are two rules. One is number one, rule for rows, and the second one is rule for column. Now, under rules for row, if all the elements in the row are less than or equal to the corresponding element in another row, then this row is said to be dominated by another row and can be eliminated from the game matrix to reduce the order of matrix. Okay, so just keep in mind, under row, if any row, the elements in any row is less than the other elements in the other row, then you can eliminate, you can remove, you can delete that particular row from your game matrix. So the rule is, if under row, if the rows, if the value, if any row, the values are less than the other row values, then you can remove that row out of your question. Okay, that's number one. Second, for rule for column, if all the elements in a column are greater than or equal to the corresponding element in another column, then this column is said to be dominated by another column and can be eliminated from the game matrix to reduce the order of the matrix. For row, if it is less, you have to remove it out. In column, if it is more, greater, then you can remove it out from your question. Okay, so these are two rules you have to remember. For rows, if the rows are less, the values in the rows are less than the other, you can remove that entire row. In column, if those values are greater than the others, you can remove it from the table, okay, from the question. So, but with these two rules, from the row, remove the less, from the column, remove the greater, you can solve the sum based on the theory of games, under which we are solving a specific part called as principle of dominance. Okay, so now let us see how to solve the sum based on this particular rule. Okay, now here they have given us, we are under the solving part principle of dominance. There are two sums on this sheet, so we are going to solve both of them one by one. Now, the first question, from the following game matrix, determine the saddle point using principle of dominance. We have player Y, under which we have three strategies, Y1, Y2 and Y3, and player X may we have X1, X2 and X3. Now, how to start the sum? Okay, very simple. First, start from the row. Check if any row is smaller than the corresponding or the alternate rows. Okay, now if I look here, check which row is the greatest first of all. Now here I can see the greater amount, 20, 36 and 24. So I'll consider this as the greatest row value. So now check the other values and check if those other row values are smaller than, see the, like if I compare the first with the third, 14 is smaller than 20, 22 is smaller than 36, 14 is smaller than 24. It means I can delete this entire row. Okay, similarly 16 is smaller than 20, minus 20 is smaller than 36 and negative 18 is smaller than 24. So what I can do here is I can delete row x1 and x2. So I'm writing, this is as per the rules based on principle of dominance. So I can, according to principle of dominance, I'm deleting row x1 and x2. Why? Because these two are smaller, the elements in these two rows are smaller than the third one. So now what I'll get, if I delete both of them, my table will be now y1, y2, y3, and I'll have x3, 20, 36 and 24. So step number 1, I deleted the rows. Step number 2, now I'll have to check from the column. Now the rule of column was, the greater the value, we'll have to remove it out. So here, from here, 36 is the greatest value. 36 is more than 20.
and even 24 is more than 20. So I can delete both these columns. So deleting column y2 and y3. Now whatever is remaining is y1 and x3, which is 20, which is nothing but my saddle point. So final answer I'll write my optimal strategy for x. For x it was x3, and the optimal strategy for y was y1, and the saddle point or the value of game okay was 20. Okay, so this is how you'll have to solve the sum based on principle of dominance. First check the rows. If any row is smaller than the other, remove that out. From the column, any row which is any column which is greater than the other, remove them out. Okay, chalo, the same we'll start here. From the following game matrix, determine the saddle point using principle of dominance. Now we have player B and player A, 3 games of 3 strategies of B and 3 of A. Now check which, okay, we are going to compare. Now let's see which is the greater value. See, 20, 18 is greater, but this is negative, so it won't be on a greater side. This also has a negative, so won't be on a greater side. So let's say we'll compare with this. 20 is not smaller than 14, so that you can't reduce this part. 8 is smaller than 14, yes. Negative 10 is smaller than 16, yes, and 10 is also smaller than 16. So I can only deleting A2 from the row. Okay, so from the row I can delete A2. So now what I'll get is B1, B2 and B3. And here I'll have only now A1 and A3 because I have reduced that part. So 20, I'll mark it out. Even I would have marked it here. This would have been the point. Okay, so 20, 18, negative 12. And I have here 14, 16 and another 16. Okay, now from the column point of view, check which column is greater than the other ones. Now 20 is a greater number, but then 20 is greater than 18, but 14 is not greater than 16, so I can't reduce it. 18 and let's say if I compare these two, 18 is greater than negative 12 and 16 is equal to or greater than 16, yes, so I can remove B2 in this case, okay, because B2 was on a higher side. So I'll write here deleting B2 from column. So if I remove B2, I will get now my value as B1 and B3, A1 and A3, 20, 14 and negative 12, 16. That's it. I can't solve it further than this. Hence, there is no saddle point in this. Okay. See, I can't reduce it further. Therefore, I'll say saddle point is not aware. Saddle point does not exist because you cannot solve it further. Okay, for getting a saddle point, you need to have only one single value. If you don't get one single value, it means there is no saddle point in this particular sum and it cannot be solved further. Okay, the rule is again same. First you delete the rows, then you delete the columns, and then when you get your final answer, you can interpret over it. Okay, chalo, these are the first two sums. Let us solve one more sum in order to understand the principle of dominance. Okay, now the question number 3. From the following, determine the saddle point using principle of dominance. Now there's a big matrix given to you all. B1, B2, B3, B4, B5 and A1, A2, A3, A4 and A5. Okay. So now let us again solve in the same order. First we'll have to check from the row. The rule is whichever row is smaller than the other, remove those rows. So first try to figure out which is the highest value, if you can find any higher value. Now if you look carefully, A2, the row A2 has 100 in the first value, which is the highest in the entire row. Okay, even 120, 110, 140, 150, none of the rows has triple digit value. It means that A2 is the dominated value. So the rule for the rows are if any row is smaller than the other, we'll have to remove them. So basically all the rows are smaller than A2. So I'll write here, we'll have to delete. So we are deleting A1, A3, A4 and A5 from rows. Okay, so what remains will be only now B1, B2, B3, B4 and B5, and we'll only have a A2 because that's the only thing which is available, which is 100, 120, 110, 140, 150. Okay, first we have eliminated the rows which are the smaller values. Now from the column, the rule is whichever column is greater than the other column, we'll have to remove it out. So from here, if you look carefully, 110 is the 100 is the smallest, and rest all the values are greater than 100. So we'll have to remove all these columns out. So I'll write here now, deleting B2, B3, B4 and B5 from column. So if those are out, so what remains is B100 and A2. That's it. That is the only value remaining. So this is my saddle point. So now I can write here, number 1, the optimal strategy for player B is B1, and the optimal strategy for A is A2, and game value or value of game is equal to 100. Okay, so this is how you all had to solve the sum based on principle of dominance under the topic theory of games or game theory under the subject OR. Okay, chalo, I hope everyone have understood that. With that, we will be ending this video here. Thank you.